Okay, so if I want to find the equation of the tangent, the order that I'm doing this in doesn't have to be specifically in that order. It's just this is the order that I approach the questions in. The first thing that I need to know is the equation of a tangent has to be a linear equation. And we know that linear equations are y equals mx plus c. We have in the past done y minus y1, mx minus x1. This is actually how I prefer to do it, and this is how I will often do the questions, but most of my students have preferred to just stick with this, so I'm going to stick with this. All right? In order to do y equals mx plus c, I need to know two things. I need to know what m is, which is the gradient, and I need to know what c is, which is the y-intercept. All right. In order to do that, I need to know two things. I need to have a point. All right, in order to do these questions, I need to have a point on the graph that I can use to work with, and I also need to have the gradient. In this particular question, we've got the equation f of x equals x cubed minus 3x plus 2, and we want to find the tangent line when x equals 3. So in terms of my point, I already have the first part of that point. I don't know what the second part is. So when I'm actually working this out, rather than jumping to the gradient, I'll just find out what's the y value first. How do I do that? Well, if my function f of x equals x cubed minus 3x plus 2, so I would then substitute in the 3, which is 27 minus 9 plus 2. What did you get for that? (27) take away 9 is? Take plus 2? 20? All right, good. I just got very confused there. So we now know what the y value is. So we've got the point 320. Now I'm going to work on what the gradient is. How do I find the gradient? I differentiate. Make sure you get your notation to say I've differentiated. 3x squared minus 3. And then I want to find the gradient when x is equal to 3. So I substitute the 3 in. (24). Okay, from there, so I've found the y value, I've found the gradient at 3. Now I'm going to find the equation. So I'm working with y equals mx plus c. I'm going to be y equals 24x plus c. Substitute in the x and the y values. 20 equals 24 times 3 plus c. 24 times 3 is 60, 72. Subtract the 72, and I get minus 52, or negative 52. So my final equation for the tangent is y equals 24x minus 52. That was the answer you should have got. Who got that? Quick show of hands if you got that. All right. Those people who didn't, does that make sense? Those people who didn't and are not nodding confidently, would you like me to come back and help you later? Okay, there is an exercise on that, but we're going to move on now. And there's some extra notes on the slides that you can access about normal lines. As I said, normal lines, they're used a fair bit in physics. Not 100% sure that you're going to be asked specific questions about tangents and normals in Year 12 exams because it's not written explicitly in the study design anymore. Next part. This is the big focus of today's lesson. At the end of today's lesson, what I want you to be able to do is to work out what the gradient is. Work out when the gradient's equal to 0. And the reason we're going to be working out when the gradient is equal to 0 is because all of our stationary points on graphs occur when the gradient's 0. Our stationary points, we've seen them in our cubics. we have maximums, we have minimums, and we have points of inflection. All of these three types of stationary points all have a gradient of 0, because at that little instant there, it's flat. At that little instant there, it's flat, it's horizontal. So the gradient's equal to 0. So we've got three types of stationary points we're going to be looking for. They're local maximum, local minimum, and points of inflection. Does anyone want to tell me why you think it is called a local maximum and a local minimum? Say it a bit louder, please, Toby. It's not the maximum or the minimum of the whole graph. So if we looked at this whole graph here, this point here is the minimum in this area. But the whole graph, this would go all the way down here. That's going to be lower, isn't it? Yeah? So it's a minimum in that local area. It's a maximum in that local area. We will probably just refer to these as minimums and maximums, generally speaking, but technically they're a local minimum, local maximum. And the gradient at all of those points is 0. Okay, so we've sketched cubic functions before. What we're going to look at today is sketching cubic functions, which we did earlier in the year, sketching polynomials, but we're going a step further. We are now also going to find the stationary points. We're going to find those maximums and minimums. So what I would like you to do, before I tell you anything, y equals 9x squared minus x cubed. Go back through your summary journal, on your whiteboard or in your workbook, can you sketch that graph? I would like you to do it without a calculator at this point in time. Go. Now that we have graphed our polynomial, we have graphed our cubic function, what we actually want to do is find these stationary points and state their nature. So the idea of the nature comes back to, is it a maximum, a minimum, or a point of inflection? This stationary point right here, is it a local maximum, local minimum, or a point of inflection? Local minimum, beautiful. It's not a point of inflection, because a point of inflection would go up, flat at that point, and then keep going up. Or a point of inflection would go down, flat at this point, and then keep going down. So it actually changes direction. Local minimum. What's the nature of this stationary point? Local maximum, beautiful, local maximum. That was easy, we got our first mark in the question. Then, find all stationary points. Have we found out what those stationary points are equal to? No. Have we found out any of them? Right. So we don't have to do any work. We know that this stationary point, we could say the local minimum is at 0, 0. Write that down. Don't need to do any calculus. Don't need to do any work, any differentiating. You've at least recognised that you know how to do the problem. You just couldn't do the next part. Okay. Success criteria. I can equate the gradient function to 0 to locate stationary points. What does equate mean? It's equal to that. So equate means make it equal. This whole success criteria says we're just going to make the gradient function, the derivative, equal 0 to find the stationary points. That's exactly what we're going to do. We know that this point occurs when the gradient is 0. We know that the derivative gives me the equation for the gradient. So if I want to find this stationary point, I am going to take my rule, y equals 9x squared minus x cubed, and I'm going to differentiate it. And I'm going to use the notation dy dx on this question because I started with y, and that's my normal notation I use when it says y. It means exactly the same as f dash of x. Different notation, same process. Okay, differentiate this. Call out the answer. 3x squared, nice. Then I want to find out when this is equal to 0. My stationary points occur when the gradient is equal to 0. Stationary points happen when gradient equals 0. So that's what I'm doing. Okay, go back to what we did up here. How do I solve that? I've got null. Highest common factor. What's highest common factor? How do I solve that? How can I get an answer of 0 when I multiply two things together? One of them's got to be equal. So if 3x equals 0, so if 3x equals 0, x equals 0. Nice. That's my stationary point right there. X equals 0. Stationary point, the gradient 0. Or 6 minus x equals 0. X equals 6. Rightio, sweet. This is my stationary point here at x equals 6. That was 4, that was 8. I probably should have moved it over a little bit. Should be about there. Make my graph a little bit better. Have I found the stationary point? Why not? I need the y coordinate. So I've found out that the x value is 6. I now have to find the y value. How do I find the y value when I know what x is? Substitute it into this rule. I'm going to substitute into this rule because this tells me what y is equal to. That's literally what the rule says. Y is equal to this. Okay, find the y value. At x equals 6. So y will equal 9 times 6 squared minus 6 cubed. Y equals 6 squared is 36. 9 times 36 minus 6 cubed is 216. 9 times 36, 9 times 30 is 270. 9 times 6 is 54. 270 and 54 is 324. How's my maths going? I hope it's okay. I could have made a mistake. 324 subtract, take 6 is 18, take 10 is 8, 108. Lucky I didn't put a scale on my graph because I feel like that 108 wouldn't match, but we don't need to make that match, it's okay. Sweet. So we're going to do two things. One, you can start on the exercise and work on this independently. It is really that simple. Stationary points, you make the gradient, you differentiate, make the derivative equal 0, find out when the gradient's 0. When you know when the gradient's 0, then they're going to be your stationary points, mark them on your graph. There are two exercises.